Hi guys, welcome back. I'm so glad you're here. This is Middle School Math with Dr. K, and this is a new series of videos on systems of equations. Now you can solve systems in 3 ways, and one of those ways is graphing, so we're going to look at that today. Here we have a system of equations, and essentially a system is 2 or more equations, and we're looking to figure out how those equations work together. So let's take a look at this on a graph. I'm going to start with this first line. It is y equals 2/5 x plus 3. So you might remember that the first point is your y-intercept. You always start there when you're graphing a line. So I need to go on my y-axis, which is on the vertical axis, and I need to go up to 3 and put a point. Now the other number, the 2/5, is my slope. So that tells me from my point at 0, 3, my y-intercept of 3, I need to go up to and over 5. And to clarify, that's up and to the right. We are almost always going to the right when we're graphing and using slope. To get the rest of my points on this line, I'm going to go down 2 and to the left 5, so I have to go backwards to get the rest of them. That is a time when we will go down and left, but typically we're going to go to the right, kind of no matter what. So this is half of my system. To graph the other half, I'll switch to blue. I need to start with my y-intercept, which is at -2. So again, I go to my y-axis, I go down 2. And then my slope on this one is -3/5, which means I need to go down 3 and to the right 5. Again, we're going to go to the right. When you use the slope, you almost always go to the right. There are a few situations where you go left, but up and to the right or down and to the right. In this case, down and to the right. I do need a few more points, so I'll go back to my starting point, my y-intercept, and go up and to the left, the exact opposite of the direction I was going before. And what you'll notice is that one of the points for the blue line that I'm working on now intersects the yellow line, and that's important. Now, when you have a system of equations, what you're looking for is that intersecting point. So you're looking to see, where do my lines meet? In this case, this point right here is where they're supposed to meet if they were perfectly drawn. And the coordinates of that point are -5, 1. So my solution is that point, -5, 1. Here's another, and I want to show you this one because not all lines will come to you in slope-intercept form. So it's important to know how to manipulate your equation to get your equation into something you recognize. Some students are highly fluent with slope-intercept form, others like standard form. Whatever way it is, it's good to know that you can manipulate an equation. So the first one is in slope-intercept form. So again, I'll start with my y-intercept. I'm going to go to 4 on the y-axis. And then my slope this time is -2. Another way to think of that is -2/1, which means I need to go down 2 and to the right 1, over and over and over, and to get as much of my graph filled in as possible. Now with systems, you never really know where that intersecting point is going to be, so you'll notice that I always plot all of the points I can fit on my graph, just in case I need them. I really want to know exactly which points this line touches. Now the next line is not yet in slope-intercept form, and that's because it has this 3y, and that's a problem. So in order to graph this, I'm going to get rid of that 3 by dividing it. When you divide in an equation, you do it to all 3 locations, or all 4 locations, or whatever you're dividing, you divide it on every single term of that equation. Now, 3y divided by 3 is just y. 2 divided by 3 is a decimal, so I'm going to leave that 2/3, or 2/3, the fraction. And then 12 divided by 3 is 4. This gives me an equation I recognize. It's in slope-intercept form. So I'll start at my y-intercept, which is -4. And then I'll graph my slope, which is 2/3. That means I'm going to go up 2 and over 3, up 2 and over 3. And I've already seen that I have an intersecting point. So I don't really need a whole lot more to my line, other than the arrows to show that it continues on forever. And the intersecting point can be found right here. That's the solution to my system. When we're solving a system, we want to know, where do those 2 equations meet? In this case, they meet at the point 3, -2. Okay, now there are some situations where you get what I would call a special solution. So not all answers are the same. It's kind of like when you're solving equations. Sometimes you get a fraction answer, sometimes you get a decimal answer, sometimes you get a whole number or an integer. And it's important to be able to roll with different types of solutions. So here's one that has a special solution, and I want you to see what it looks like when it's graphed. In this situation, I'll start with my first line. I've got a y-intercept of 3 and a slope of 2. Remember, you can turn that slope into a fraction by making it 2 over 1, which tells me I need to go up 2 and over 1, up 2 and over 1. Again, I'm really going up and to the right, only until I need to get to the other half of my line. Then I'm doing the exact opposite. I'm going down and left. This is another example where the second line needs to be manipulated a little bit. So I see that I've got 4y, but I really need just y. So I'll divide by 4. And it's important to remember that you divide every single term by 4. So if you're dividing in an equation, you divide everything. The same goes for multiplication. In this case, 4y divided by 4 is y, 8x divided by 4 is 2x, and 36 divided by 4 is 9. Just like on every other piece, every other equation I've graphed, I've started on the y-intercept, so I'll start at -9. And I see that my slope on this one is also 2 over 1, which means I need to go up 2 and over 1, up 2 and over 1. And what you'll notice is both lines had that slope of 2 over 1. So what's happening here? Are they ever going to meet? In this case, no. These are called parallel lines. Lines that have the exact same slope are parallel, which means they'll never meet, which means in regard to our solution, in regard to this system, there's actually no solution. This is one special solution type that you'll come across. Lines that never meet don't have an intersecting point, and therefore there is no solution. The last example gave you one type of special solution you might come across in a system of equations problem. This one actually gives you a completely different type of solution. So let's check it out. Here I'm going to start with my first line. It's written backwards from what we're used to, but it's still in slope-intercept form because y is already isolated. So that means my intercept is at -5, and my slope tells me I need to go up 1 and over 3. Again, I'm going to the right until I run out of room. Then I'll go back to my starting point and I'll do the exact opposite. I'll go down 1 and left 3, over and over and over until I've used up my entire graph. And this is what I'm left with. Now the second equation, I gave you something that looks a little different. This is called standard form. Standard form is when you've got x and y on the same side. One or either of them might not have a coefficient. In this case, they both do. And what we really need to do is get that y by itself. So my first step is to get rid of that 1x that's on the same side as the y, and I'll do that by subtracting. What's strange is you have here two terms that are not like terms. So when I write that, I'm going to say I have 15 minus 1x, and on the right-hand side, I have -3y. To get my y all the way by itself, I will divide by -3. And again, remember that when you divide in an equation, you divide everything. Every term gets divided. So 15 divided by -3 is -5. -1 divided by -3 would be a decimal. So I'm going to rewrite that as positive because two negatives make a positive. 1/3 x. And then on the right side, I have y isolated. Now what you'll notice is this equation looks very similar to our original equation. So let's graph it and see what happens. I see that my y-intercept is -5. And I see that my slope tells me to go up 1 and over 3. And what's happening when I do that, and then I go down and over to get to the other side, is that my blue line is completely overlapping my yellow line. Now this is a different solution type. This is not a no solution. And what's important about this are these are lines that have every single point in common. They don't have one point in common or no points in common. They have all of their points in common. So this solution type is when there is infinitely many solutions. It's a little bit of a mouthful, but it essentially means they have every single point in common. So what I need you to know when you leave here today is that you can graph a system of equations and you can find the solution. Now there are three different solution types to be aware of. The first is that if you have two lines that intersect, they're going to have one solution, and the solution is where they meet. So this guy right here, this point, the coordinates to that point specifically are the solution. Sometimes you have two lines that are completely parallel. and those lines have no solution whatsoever. You'll recognize those lines because they'll have the same slope. You could also have two lines that are completely overlapping. You'll recognize those lines because actually they'll have both the same slope and the same y-intercept. Same equation entirely. So I'll just write same equation. You might have to navigate around that equation a little bit. You might have to isolate y before you recognize that they are in fact the same equation. You might need to get it into slope-intercept form or get it into standard form. Whatever you do, they should come out to the same thing, same y-intercept and same slope. And that's when you have infinitely many solutions, which I'll abbreviate here, IMS. That means they have every single point in common because they're the same line. So this should give you a start on solving systems. Like I said, there are 3 different ways to do it, but graphing is a really nice way to visualize a solution to a problem. There are times when you'll need to algebraically solve, and we'll cover that in the next video. I'll link that here in case you're looking for more help with systems of equations. Otherwise, go solve all the systems and have a great day.